All right, I see 3, 4, 5 people connected. I'm going to start, okay? And you know I'm recording the video so you can watch it later. All right, so let's open Electroland. And we have a new objective here, so you can see balloons and static electricity. Okay, we're reading the story first, okay? Here you have 2 videos that I want you to watch later after the explanation. Some of you might already watch the video, but don't worry. Okay, tarea. The first point today, okay, is mark the 3 examples of atoms, nitrogen, oxygen, and fluor you built on the simulation laboratory and copied on your notebook following my example. If you remember the other day in the virtual laboratory, we were building atoms, the nucleus with protons and neutrons, electrons moving around, all right? So here you have the solution, okay? We did the example with the hydrogen and the carbon, and then I gave you these 3 elements, nitrogen, oxygen, and fluor, to do the simulation on the laboratory and then copy them on your notebook, okay? So nitrogen has the atomic number 7, so this means that it has 7 protons and 7 neutrons in the nucleus and 7 electrons moving around. Remember that the first orbit can only hold 2 electrons maximum, and then we complete until 7, so this is 1, 2 in the first orbit, and then 3, 4, 5, 6, and 7 around the second orbit. Oxygen has the atomic number 8, so it has 8 protons, 8 neutrons, and 8 electrons, okay? So protons and neutrons inside the nucleus, and then electrons moving around. And finally, fluor, that has got the atomic number 9, 9 protons, 9 neutrons, and 9 electrons. Protons and neutrons in the nucleus, and then 2 electrons on the first orbit, and we complete until 9 on the second orbit. As you can see, all the 3 atoms are electrically neutral because they have the same number of protons and electrons, all right? Okay, so that is the first part, okay, marking the homework. Second part, the explanation video. This is where we are. Simulation laboratory. Okay, we have balloons and static electricity. So the first thing I'm doing is explaining you, okay, the difference between static electricity and current electricity. I see some students that are sending me messages. All right, perfect. How many people is connected? Same people. All right. So, static electricity versus current electricity. We need to have some concepts clear first, okay? We have this pair of words which are antonyms, static and current, okay? Static means that there's no movement, okay? And current means that the things are moving, that flow. The second concept we need to have clear is the concept of attraction and repulsion. Remember that in the book and in the previous objectives, we learned that different charges, when they are positive and negative, they attract each other, okay? So they get closer. But on the other hand, we have repulsion, which means that they separate, okay? They don't get closer, but they go further. They repulse each other. Another concept that we need to understand is balance and imbalance. When there is a balance, we mean that, okay, the 2 things have or are in the same position, let's say, okay? But when we have an imbalance, what we have is a difference, all right? If we're talking about charges, the balance of charges will mean that we have the same number of protons and the same number of electrons, same positive charges and same number of negative charges. The imbalance will be produced if we have more protons than electrons or more electrons than protons, okay? That will be the imbalance. And the last concept we need to understand is the difference between insulator materials and conductors, okay? Insulators are materials that do not conduct electricity. For example, rubber, glass, oil, diamond that is made of carbon, or dry wood, all right? Conductors are materials that conduct electricity, through which electricity flows. We have the silver, gold, copper, steel, and also seawater, okay? Or water in general. As you can see, silver, gold, copper, and steel, they share one characteristic, and is that all these materials are metals, all right? So we can understand that metals are good conductors of electricity, okay? So remember, difference between static and current, movement and no movement, attraction and repulsion, balance and imbalance, equal and different, and insulators and conductors, okay? They do not conduct electricity, and they conduct electricity. All right, so what is static electricity? Static means no movement, as we learned before. It happens when electricity accumulates in one place. That's why it's called static, because it accumulates in one place, okay? There is an imbalance of positive and negative charges. So in this place where electricity accumulates, there is an imbalance of positive and negative charges, okay? They are not in a balanced situation, but we have a difference of charges, more positive than negative or more negative than positive charges. And it happens between two insulator materials. Remember, materials that don't conduct electricity. Here I put some photos of examples in which static electricity is produced. For example, when we rub out a balloon against our hair, okay? There is an imbalance of electrons and protons, so static electricity is stored. Another example happens sometimes when we wear some clothes and the clothes get stuck to our body and we cannot separate them from the body. That is because an imbalance of charges between our body and the piece of cloth that we are wearing is produced, and we have static electricity in that situation. Another situation that is very common is when we brush our hair or when we comb our hair and we're using a plastic hairbrush. Sometimes it stores static electricity, again, because there is an imbalance of charges between electrons and protons, all right? Or I don't know if this has ever happened to you. With modern cars, it's more difficult, but if you have an older car, sometimes happens that if we touch the car and there is an imbalance of charges between the car and our body because we are touching the ground with our shoes that are usually covered in rubber, okay, in rubber material, we experiment a kind of shock, okay, that comes out of the car. So this is another situation in which static electricity is produced. And I left this one for the last one because this is the one that is related to the videos in the story of Classcraft, okay? About how does lightning work, how do lightnings are produced, and it is because of static electricity, okay? So I want you to watch the videos to understand how the imbalance is produced, how the charges move in the clouds, and how the lightnings are produced, okay? And now we're going to explain what is current electricity. Remember that current means that flows from one place to another. So the electricity, or the electrons in this case, they are moving, all right? It happens when the electrons move from one atom to another, from atom to atom. It happens when electrons flow within conductors. So in this situation, we're talking about conductors, materials that conduct electricity, like metals or water. And electrical circuits allow electrons to move or flow. So looking at these photographs, we can see how wires that are used to connect different machines that we have at home, like the refrigerator, the toaster, the television, the computer, okay? So wires, inside the wire, we have metal materials like copper, usually, that allows the electricity to flow, the electrons to move, okay? So it is going to conduct electricity. Or the electrical net that transports electricity from power stations to our houses. And here, this picture represents the electrical circuit that we mentioned here in a house. So how the electrical circuit distributes electricity around the house. So different machines like the television, okay, the telephone, the lamps, electrical radiators, the washing machine, they're all connected to the electrical net. So we can use them and they produce work, all right? So these are basically the ideas and the differences of static electricity and current electricity. Let's remember, static electricity implies no movement. It happens when electricity accumulates in one place. There is an imbalance of positive and negative charges, and it happens between two insulators, okay? Two materials that don't conduct electricity. Current electricity means that it flows from one place to another. It happens when electrons from one atom move to another atom. It happens when we have conductors, when we have conductive materials, and we need an electrical circuit for the electricity to flow, all right? Well, next point after the explanation will be in the book, okay? So I'm going to open the book. This is what we learned about atoms, okay, what is the structure of atoms. We saw that there are three particles, protons, neutrons, and electrons, all right? And that an atom can be electrically neutral if it has got the same number of protons and electrons. But electrons can move, okay? So for example, if you rub two objects together with the balloon and the jumper, the electrons can move from one object to another, all right? And here is the point where the imbalance of charges is produced. The balloon is negatively charged because it has got more electrons than protons. So we can understand that the electrons from the jumper moved to the balloon. And now the jumper is positively charged because it has got more protons than electrons. We also talked these days about the attraction and the repulsion, all right? So we see here that different charges, positive and negative, attract each other, while equal charges, positive and negative, they repel each other, all right? And the charged particles is what results in electricity. So if we open, or if we turn to the next pages, 70 and 71, is where we have the static electricity and the current electricity, all right? And it says that electricity can build up in one place or flow from one place to another.
What causes lightning?
Oops, sorry.
Electricity can build up in one place or flow from one place to another. When electricity gathers in one place, it is known as static electricity.
Okay. Sorry. Okay, so as you can see here, okay, in the book, all right, here it explains the differences between static electricity and current electricity, okay? But I don't want you to read the circuit, okay? Because this will be for our next lesson, all right? Okay, after the book, okay, we're going to open the simulation laboratory, all right? So, let's go to the virtual laboratory. Okay, we have 7 people now, all right. Okay, so this is our virtual laboratory today, okay? First, I'm going to explain you the different functions and buttons that we have here so you can understand how it works and you can do the activity that I am proposing you. Okay, so here you can see that we have a jumper, all right, that it has got, that is charged with protons and electrons. We also have a balloon and we have a wall, all right. Different options that we have here. You can show all charges, okay, protons and electrons, or you can't show any charges, all right. Or you can also show the differences of charge that now it doesn't appear, but if I rub the balloon against the jumper, you can see how the differences or the difference of charges is shown. Okay, we can only see the protons on the jumper and the electrons in the balloon. If we show no charges, again, nothing appears, and if we show all charges, we can see all charges on the wall, on the balloon, and on the jumper, okay, or sweater. Okay, here this is the reset button, so we can, okay, reset the initial situation. Here we have this option to use 1 or 2 balloons, all right, and you also have the option to remove the wall, okay, so it appears or it doesn't appear. Okay, let's start with 1 balloon, all right. Observe that if you rub the balloon, okay, against the jumper, the electrons move from the jumper to the balloon, okay? So this is a situation of static electricity. The electricity is stored or it accumulates in one place. There is an imbalance of charges because now we have the sweater that is positively charged and the balloon that is negatively charged, all right? And we're going to observe now that the balloon now doesn't stay in its initial position, okay? It is attracted by the jumper because remember that different charges attract each other, all right? Okay, I'm just checking how many people we have. Lauren, what happens if I move the balloon to get next to the wall? All right, as you can see, the electrons are repelling each other because since the balloon is negatively charged and the wall is now neutrally charged because it has the same number of protons and the same number of electrons, the electrons move against the wall. They move further from the balloon because negative and negative charges repel each other, all right? Okay, let's reset the situation, okay? And let's see now what happens with the 2 balloons, all right? As you can see, first I can put both balloons together. Both balloons can go next to the wall, all right? And now I'm going to rub the green balloon against the sweater and the yellow balloon as well, all right? Both balloons are attracted by the sweater, as you can see. And what happens here? I cannot put the balloon next to the yellow balloon. Ah, I see. It's because both are negatively charged. So the yellow and the green balloon, they repel each other, okay? But if I try to go behind or beneath the yellow balloon, finally, the sweater can attract the green balloon as well, all right? So what I want you to do before doing the next activity is practicing, okay, with the simulation. And then go to the 4th point, virtual laboratory test. Okay, so you open it. And this is what you will see. Here you will have to write your name, okay, and class, all right? And you have different situations. So what I want you to do is working at the same time with the test or with the questions, the exercises, and the application, all right? Picture 1, I give you the situation, okay? So observing this situation, you can reproduce it on the virtual laboratory. Okay, you reset the button and you have the sweater neutrally charged, the balloon neutrally charged, and the wall neutrally charged. Okay, so you have to answer these questions. What is the sweater's charge in this situation? What is the balloon's charge in this situation? You have three options and you answer to the question. Okay. In picture 2, okay, the situation has changed. Observe that we have the option show charge differences. We have one balloon, okay? So I'm going to reproduce this situation on the laboratory. Show charge differences. And I have to put the balloon here. Okay, so now I have the same situation. I observe what happens and read the question. Which object is negatively charged now? Which object is positively charged now? So you choose the correct option. And number 5 says compare picture 1 and picture 2. So you compare 1 and 2. And describe what happens when you rub the balloon on the sweater. What happens with the electrons? Okay, so comparing these two situations, I want you to explain with your words, with your ideas, what happened here. How have the electrons moved? All right. We continue with the third situation, picture 3. All right. So I'm going to reproduce this situation because it says look at picture 3, create this situation in the virtual laboratory, see what happens with the balloon and explain. So I'm going to reproduce the situation. The sweater positively charged, the balloon negatively charged, and the wall neutrally charged. And it is with the option show all charges. So I show all charges and I place the balloon here. Okay, I want you to observe what happens if in this point, okay, you release the balloon. And explain what happened, okay, to the balloon and why you think this happened. In picture 4, we're using the two balloons and all charges. Okay, so look at picture 4, create this situation in the virtual laboratory and try to put the green balloon next to, not on, okay, just next to, so yellow and green together, not on it. Is it possible? Yes, it is. No, it isn't. And why? Okay, so you recreate the situation with the two balloons together, all right? Here, observe that I'm going to reset it, okay? Two balloons, and I need to have the sweater positively charged, the balloon negatively charged, the green balloon, the yellow balloon negatively charged too, and the neutral wall, okay? So I need to rub the green balloon against the sweater and the yellow balloon as well. So now I have negatively charged, and positively charged, okay? And what I want you to do is trying to put the two balloons together, okay? The green balloon and the yellow balloon. And tell me if it's possible or if it's not possible. And explain why, all right, with your ideas. And then you send your answers. Okie dokie? I forgot to tell you that during this week, I'm going to send you your results of the listening practice, okay? And also when you finish these questions about the virtual laboratory, about the balloons and static electricity, I will also send you your results so you know if you have them right or wrong. Okie dokie? And that's it, all right? This is going to be the end of the mission for today, all right? So I hope that everything is clear, and if you have questions, I'm here to answer all your questions. Everybody, take care, and we'll see you in our next lesson.